In this video, we're going to look at the last two examples of graphing radical functions. So in example 7, we have y equals 1/2 and then the square root of x plus 3. So there's actually two things that are affecting our graph. We have a coefficient of 1/2, and then underneath the radical we have a positive 3 that's added to the x. So the 1/2 part, let me write that a little better. The 1/2 coefficient would make our graph less steep. So looking like it kind of is vertically compressed, I guess is another word for it. And then the positive 3 underneath the radical is the left or the right. And remember, when it's a positive 3, that it actually goes to the left 3 units. And so I've already chosen some values that'll be easy for us to plug in to save some time. So we have -3, 1, 6, and 13 that we're going to substitute for x. So let's plug in 1/2 and then the square root of x plus 3. So I'm going to zoom in for a minute to focus on this part. So we have 1/2, let's see. Let me grab a little smaller pen to fit this all in. We have 1/2 and then the square root of -3 plus 3. And we have 1/2 the square root of 1 plus 3. And then 1/2 times the square root of 6 plus 3, and then 1/2 and the square root of 13 plus 3. And so that simplifies to be 1/2 the square root of 0, 1/2 times the square root of 4, 1/2 times the square root of 9, and 1/2 times the square root of 16. And then we can simplify that. So half of 0 would just be 0. Half of the square root of 4, which was 2, would be 1. Half the square root of 9 would be 1.5. And then half the square root of 16 is 2. And then let's graph those points over here. So we have -3 goes with 0. We have 1, 1. We have 6 goes with 1.5, so that'd be about right there. So notice that this graph shifted to the left 3 and is less steep. It looks like it kind of got stepped on. So we also call that a vertical, it's vertically compressed. So it had a vertical compression by a factor of 3. Is a very formal way to say that. It's less steep. And then the domain and the range, let's pick those out. So the domain is still what your x can equal. So in this case, x starts at -3 and then it goes up from there. So we say x is greater than or equal to -3. And the range is what the y values can be. So your y value starts at 0 and then it's going to go up. So y is greater than or equal to 0. All right, so we have one last example. Y equals negative square root of x plus 4. So the negative and the 4 are the two parts we need to discuss. How is the function's graph different from the parent function? So the negative makes it open down or reflect over the x-axis. And the plus 4 is not underneath the radical, so that makes it shift up 4 units. All right, so let's plot some points again. So we have 0, 4, 9, and 16 are going to be easy ones to use to plug into our function. So let's substitute those for negative square root of x plus 4. So we have negative square root of 0 plus 4, negative square root of 4 plus 4, negative square root of 9 plus 4, and negative square root of 16 plus 4. So then negative square root of 0 plus 4 would just be 4. Negative square root of 4, so that's -2, plus 4 is 2. Negative square root of 9 would be -3, plus 4 is 1. And then negative square root of 16 would be -4 plus 4, which is 0. And then we just plot those points. So we have 0, 4. We have 4, 2. So 4, 2, and then the rest don't really fit on our graph very well, but we have enough with those 2 points to have a decent sketch. So remember our graph opened down. We knew because it had the negative in the front, and this graph shifted up 4 units. So that looks like the right graph. And then we just need to determine domain and range, and we'll be finished with our last example. So domain is always what can your x be. So in this case, x starts at 0, and then it goes up because it goes to the right forever. So x is greater than or equal to 0 is our domain. And then the range starts at 4, and then it goes down. So the range would be y is less than or equal to 4. All right, so that's it for the rest of the examples of graphing